Hey, classwork, contemplations, what today's lesson is all about. Now, what we're going to get into today is Chapter 2, the approaches to problem solving. And the first thing we want to talk about is the difference between mathematics and arithmetic. Facts like 9 times 8 equals 72, written 9 parentheses 8 or equals 72 or 9 times 8, but we really want to avoid the X notation there. 9 times with a dot, that works as 72. So that kind of fact, number fact, like 9 times 8 is 72 or 3 plus 7 equals 10, that's arithmetic. Math is very, very different. A lot of people think math is arithmetic. Arithmetic is a subtopic within math. Math is much, much deeper. Math seeks to find and apply the truth to the real world, and then by extension from that to our lives. For example, here's a really important one that we're going to use throughout today's lesson. What are 3 puppy dogs plus 7 puppy dogs? When I ask that to students, they'll usually tell me 10. And that's not true. That's arithmetic. 3 plus 7 is 10. It is 10 puppy dogs, and that's mathematics. That's seeing things mathematically, thinking mathematically. Herein lies mathematics, mathematical thinking. 3 x's plus 7 x's are 10 x's. What is x? Well, x could be anything. So what that means is that 3 of anything plus 7 of that same anything is going to be 10 of that same anything. That's a truthful conclusion that we can make. So that means 3 puppy dogs plus 7 puppy dogs are 10 puppy dogs. It also means that 3 kitty cats plus 7 kitty cats is 10 kitty cats. Or something you've been doing your whole life, or just about, $3 plus $7 is $10. Or if you're playing sports, you might say 3 home runs plus 7 home runs is 10 home runs. Or if you go shopping, you might say 3 pairs of jeans plus 7 pairs of jeans is 10 pairs of jeans. But this is what it does not say, and this is an extension of it. You know how, like, if you go shopping and if you buy 3 pairs of jeans and 7 pairs of jeans, when you get home, you don't get 7 fleece tops? No, of course not. Or likewise, if you're trying to figure out the price of something, or let's say if someone comes up to you and says, let's do something really silly. What are 3 car phones or 3 cell phones and 7 iPhones? 3 cell phones and 7 cars. Well, 3 iPhones or 3 cell phones and 7 cars, or 3 cell phones and 7 cars. You can't combine them. Now, if I said, what are 3 cars and 7 cars? That I could do. That's 10 cars. But I can't do 3 cell phones and 7 cars. So this brings us to this big mathematical understanding. The big understanding is this. Whenever you add or subtract anything on the face of the earth, it has to be the same kind of thing. It can't be different things. So 3 puppy dogs plus 7 kitty cats? Well, it's 3 puppy dogs and 7 kitty cats. You can't get smart and say 10 cat dogs like the cartoon character. Nope. You could say 10 pets, because a puppy dog is a type of pet, and kitty cats are a type of pet, and 7 pets and 3 pets make 10 pets. But we'll get more into that later on. For now, what you need to understand is that 3 of anything plus 7 of that same anything gives you 10 of that anything. And you can only add things that are alike. Okay? Specifically, these ideas apply to units, be they of measure, currency, or any method of classification. Let's work with the units of measurement and currency. For example, what's 5 feet plus 5 feet? It's not 10, it's 10 feet. What's 11 inches take away 4 inches? It's 7 inches. What's 10 feet take away 6 inches? Well, I can't do that. One's a foot, one's an inch. So I have to get them into a common category or a common unit. Now, I can trade 6 inches in for a half a foot, and then 12 feet minus a half a foot is 11 and a half feet. Or I could trade 12 feet in for 144 inches, and then I could say, well, 144 inches minus 6 inches is 138 inches. But the only way to combine them is to make sure they're the same unit. Feet and feet, inches and inches. That is mathematics. The 12 minus a half or the 144 minus 6, that's the arithmetic part. The understanding to get into a common unit, now we're talking about math. We can do the same exact thing with currency. $5 plus $2 is $7. €5 and €2 is €7. But $5 and €2? Now you got to go to the bank, you got to get a converter, you got to do a lot of things to convert one into the other in order to be able to combine them. Just like you could convert inches to feet or feet to inches in order to combine them. And that is what we're really going to talk about today. But before we do that, I want to do a brief review of fractions. 3/5 plus 1/5 is going to equal 4/5. In other words, 3 of this thing called a fifth. I don't even have to know what a fifth is. It doesn't make a difference. All I know is 3 of anything plus 1 of anything is 4 of those anythings. So if the anything is a fifth, then 3/5 plus 1/5 is 4/5. Now in fractions, we write a fifth this way, but it's the same thing as the word dogs before. We just have a different way of writing fifths this way. So remember all that stuff about how you need a common denominator when you add? What they were really saying is you need a common category when you add, or a common unit. Like, for instance, what we just did with feet and feet. I could add feet and feet, but I couldn't add feet and inches. So if I wanted to do 4/9 minus 2/9 equals 2/9, now with fractions, I write it this way. 4/9 minus 2/9 is 2/9, and that makes sense. But what if I said 5/7 plus 1/12? See, the previous questions, the first one is like saying 3 feet plus 1 feet. And the next one's like saying 4 inches minus 2 inches. But now I'm saying 5 feet plus 1 inch, because sevenths and twelfths are different. So I can't do that the way it is. And I need to get into what we used to call the fact that these needed a common denominator. Okay? So now you see why adding and subtracting fractions needs a common denominator. Oh, by the way, 3 of anything plus 2 of anything is 5 of that anything. But 3x's and 2y's. So 3x and 2x is 5x. But 3x and 2y's, that's it. It's simplified. You can't do anything with that. Which is the same exact thing that we've been doing with fractions. Now, if you could change fractions a little bit and get a common denominator, kind of like trading in puppy dogs and kittens and making them pets, now you can begin to combine them. And when you begin to think that way, you begin to think mathematically. The great thinker. In summary, we can add or subtract numbers only when they have the same kind of units or the same category. We can multiply and divide quantities with the same or different units. It doesn't make a difference. Multiplying and dividing is very different than adding and subtracting. Adding and subtracting must be the same kind of thing. Okay, so what are some keywords that indicate units and what's going on here? We do want you to know that per means that you're going to be doing division somewhere. Square is the second power that you raise to. Cube is the third power. And if you see a hyphen, it indicates multiplication, like kilowatt hours means kilowatts times hours. Miles per gallon in division, that word per means to divide. So that means miles divided by gallon. Miles per hour, miles divided by hours. Okay? When you do some unit conversions, it's simply multiplying the number by 1. That's one way to do it. For instance, if I want to do convert one, some things I could convert are hours, 24 hours in a day, 100 centimeters in a meter, because they are the same things, okay? And there's 24 hours in one day. Now, that's an example of unit conversions, and that's what we're going to get into. So what we mean by that is this. We could employ this idea. If we were asked to convert a distance of 9 feet into inches, one way to do it is where you create a conversion factor and you rewrite it so that the numerator and the denominator cancel each other out, and you're left with the units you're looking for. So I want to convert a distance of 9 feet into inches. So here's my 9 feet. And to convert to inches, there's 12 inches in 1 foot. Now, this 12 inches over a foot, that equals 1, because 12 inches and a foot are the same thing, and anything divided by itself is 1. And I set this up specifically with feet on the bottom so that I can kill off or cancel out the units of feet. And then I just do the math that's left. 9 times 12 is 108 inches. And that is one way to do it, the way in which you set up your cancellations, okay, your killings of the feet and feet. Little cartoon about chains of conversions. I actually did this today. I was talking to someone about how old the Earth is, and the number of ways to make DNA. We're having a conversation, so I had to do one of these massive chain conversions just today in a conversation on Facebook. All right. So this is a massive change of one, okay, and it shows why you get 8,121,600 seconds in the summer vacation, because it's 94 days, 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. And what you can see here is that we set up the days to cancel, the hours to cancel, and the minutes to cancel. So the only thing you're left with is seconds, and then you multiply the numbers that remain, 94 times 24 times 60 times 60. Okay. So here are some example problems. Convert 5 yards to feet. Convert 240 inches to feet. Convert 18 yards to inches. And we're going to compute these in two different ways. One method like we just did, okay? And the other method I'm going to introduce to you. And you can do whichever way you like to do. It's all completely up to you. So, one of the ways is the way we just did. We want to convert 5 yards to feet, and there's 3 feet in a yard. What I'm doing here is I'm setting up the cancellation of yards, and I get 15 feet, because the only unit left is feet. Let's do 240 inches to feet. There's 1 foot in 12 inches. Notice, last time I did the 12 inches in the top. This time I do it in the bottom, because I always want to set it up so that the units go die-die and I'm left with what I'm looking for, which in this case is feet. And I'm actually going to end up dividing. 24 divided by 12 is 20. Or pardon me, 240 divided by 12 is 20. And then number 3, yards to inches. Sometimes you get into your multiple or chain reducing here. 18 yards to become inches. There's 3 feet in a yard. Notice I set up the yards to go die-die. And there's 12 inches in a foot. Notice I set that up to go die-die. And notice it's the reciprocal of the previous problem. It's whatever I want the answer to be. I want the answer to be inches. So I put inches per foot. Why does the foot have to go on the bottom? Because I need the feet to cancel. I need the yards to cancel. There they are. I'm left with 18 times 3 times 12 inches. And I get 648 inches. So that's a perfectly good technique, where what you do is you align it so that you get the cancellation process and you're left with the units that you want to have. But there's a second technique. The second technique is to say, am I going from big to small? If that's the case, I multiply. Am I going from small to big? If that's the case, I divide. And then use whatever the conversion factor is. So for example, if I want to go from 5 yards to feet, if I want to go from yards to feet, a yard is bigger than a foot. So that's big to small, means I got to multiply. The reason you multiply is there's 3 feet in every yard, so you got to multiply. The factor is 3. 5 times 3 is 15. So the answer would be 15 feet. Next one, inches to feet, that's small to big. Whenever you go from small to big, you divide. And in this case, the factor is 12 inches in feet, 12 inches in a foot. 240 divided by 12 is 20. And again, they wanted feet, so it would be 20 feet. Next one would be 18 yards to inches. Now, yards, you can do this in 2 steps. First, if I want to go yards to feet, that's big to small, so I got to multiply. And the factor is 3, because there's 3 feet in the yard. 18 times 3 is 54. But now I have 54 feet, and I want to go to inches. Again, that's big to small, so I have to multiply again. This time the factor is 12. 54 times 12 is 648. So whichever technique you like, you can do. They both work fine.